Okay, 7.3, we are identifying similar triangles using angle-angle, side-side-side, and side-angle-side similarities. So angle-angle is when you have two angles in one triangle that are congruent to two in another triangle. That means that they have to be similar. Side-side-side, if you have the corresponding side lengths of two triangles are proportional, then that means the triangles are similar to each other. And if you have side angle side, so that means the angle in between the two sides. So you have the angles are congruent and the side lengths are similar, or proportional I should say, then that means that those triangles would be similar. So these are three different postulates that we use for triangle similarity. So the first example says determine whether they are similar. If so, write the similarity statement and explain your reasoning. So first one on part A here, I'm looking at what do I have, what can I use on this diagram. So if you remember back from the first trimester, whenever you see this bow tie look, we have these angles here. So if I'm going to explain this, I can say angle QXP is congruent to angle NXM because they are vertical angles. So that's one thing that we can say. Now these little arrows on here, that means that these lines are parallel to each other. So now I could use the fact, drawing either one of these lines in here as a transversal, I could say this angle would be equal to that angle. So I can also say angle P would be congruent to angle M because they are, if you remember this, those would be alternate interior angles. Alternate interior angles. So since I was able to show that two sets of angles are congruent here, that means I can use that angle-angle postulate on the top there. So I'm going to write the similarity statement. So I have to make sure that I go in order here. So if I'm going to go from, let's say, Q to X to P, the angle that goes with Q would be angle N. So I would go NXM then. And that is by angle-angle. Okay, part B on here. We're going to be checking similarity here. So I can see in here in these two triangles that they're both going to share this angle. So I have the little triangle NMP and I have the big triangle RMS, and they both share that angle M there. So I'm going to say angle M is congruent to angle M by the reflexive property. Now I have side lengths. I need to see if these side lengths correspond to each other. So if I do this side here, which is 10, over the whole length of the whole triangle, so 15 plus 10 would be 25. So 10 divided by 25, that is the same thing as 2/5. Now let's check the other side. I have 12 over the whole thing would be 30, which is also the same thing as 2/5. So that's telling me that I have proportional sides. Sides are proportional. So I'm going to say that triangle NMP is similar to triangle RMS by, I have side, angle, side there. Okay, last one. So we could use side, angle, side again here because see I have vertical angles again. But this time let's try doing side, side, side on here just so that we get one of each. So let's check to make sure that the sides are proportional to each other. So I have a 9 compared to a 6, which simplifies to 3/2. I have a 6 and a 4. Let's see if those, yep, that will equal 3/2. and a 7.5 over 5. So when you have the decimal in the fraction, what I would suggest doing is dividing it on the calculator and saying, is 1.5 the same thing as 3/2? And you can confirm on the calculator that it is. So since these are all sides are proportional, so I can say triangle, we got to make sure we go in the right order, A, B, C, if I start with that. A went with D in this triangle, so triangle D, E, C. And that would be by side, side, side on this one. So there we used one of each to show that those triangles were similar to each other. Okay, example 2. We have some information here along with the diagram that goes with it, and it's telling us that those sides are parallel to each other. So we know that these would have to be similar triangles then, because if these are parallel, I have alternate interior angles and I have vertical angles. So these have to be similar to each other. So I'm going to say triangle, let's say TUQ is similar to triangle RSQ by angle, angle again. So what we're going to do is set up a proportion again. So if I do small over big, if I have 4 over 10 equals, and then we're going to simplify, we're going to solve this. So if you want to, you can simplify this first and then do your cross multiplying, so that becomes 2 over 5. And then do the cross product. So this becomes 4x plus 20. So I would subtract 4x from both sides, subtract 15 from both sides, and we're going to end up with x equals 5. And then go back to reread. Was it asking for x or what was it asking for? So it's asking for the measure of RQ and the measure of QT. So RQ is going to equal 5 plus 3, which is going to be 8. And QT is going to be 2 times 5 is 10, plus 10 is 20. Okay. Last example. So we have Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow as 242 feet at the same time. What was the height of the Sears Tower? So what we're going to do whenever you're given an application problem like this is we want to kind of sketch it out. So here's my little light pole. Okay, there's the light coming out of my light pole. And here's my Sears Tower. Okay, so they are both going to have a shadow on them. So we have the light pole is 12 feet high, and its shadow was 2 feet long, because here's the sunshine up here causing those shadows. The building, we don't know how tall that is. That's what we want to find, but we know the shadow was 242 feet. So what I really have here is two similar triangles. Because of the fact that they're going to be right triangles and the sun is at the same height at the same time there, so I'm going to set up a proportion for this. So I can do 12 over 2 equals x over 242. So I did object over shadow here. So if I do 12 times 242, that gives me 2904 equals 2x. which means 1452 feet would be about the height of the Sears Tower there. Don't know if that's accurate or not. You'd have to look it up and see. So you have 2 to do here. So be careful with this. I'm going to give you a clue. They have to have 2 angles that are equal in order to use angle on there to say that they're similar. So decide if you think that they are or not. And lastly, for your joke, how do you turn soup into gold? You add 24 carats. Okay, hope you have a wonderful rest of your day, and make sure you're kind to someone today.